All right, so here is the 2024 Northern Hemisphere Exam 2. So we're going to go through this together. Okay, so here we go. So data, I'm starting with data analysis. So we have three variables here: day, LLT or lowest low tide, and highest high tide. So often with data, there's all this information that you don't really need to look at. Hopefully you will have worked out in reading time though what's important and what is not. So for question A, we've got the HHT and we're looking for the mean. Now, the best way to do this is just to chuck it in the CAS. You can do it old school, but you're more prone to errors. So here we go. We've got our data already inputted. So we've got menu 411. We've got one list. Our data that we're looking for is HHT. And, whoops. No. It's okay. Oh, what happened? Just go back to our other page, please. Okay. The data that we're looking for is our mean, which we know is by the X with a line on top, and it's one decimal place, so that is 1.6. Okay, jumping down to the next question is standard deviation. So again, just in there, standard deviation is the SX, and it is 3 decimal places, so we have 0.185. And we need our CAS again for this one, because now we need our 5-number summary. So our 5-number summary, I'll just move this down so you can see it all. Whoops, that was a bit big. Whoopsies. 5-number summary, we've got the minimum. Sorry. All right, we've got minimum. Which we've lost. That's okay. Whoop. Here we go. Minimum and Q1 are the same value, so 1.42. Now, when we're here, it's really important that we look at what our scale is. So there are 5 there. So 1.42 is the first line there. Now, when you do it, please make sure you just do one line and not what I just did. So just one line. Our next one, we've got our median, which is 1.55, and our Q3, which is 1.74. So 1.55 is in the middle. 1.74 is 2 across, and then 1.92 is the 1 across. Now, you should be using a ruler when you do this, but I'm on the computer, so I don't have to do that. Now, just be aware that because the minimum and the Q1 are the same, we don't have any lower end whisker. Okay, now we have a 5-number summary for LLT here. Now, we want to show that the minimum is not an outlier. Now, the way that we find outliers is with our fences. So we're going to calculate our fence. Now, show that means we have to show every step of the process. So we find our IQR, which is Q3 minus Q1. And that's going to give us 0.26. And then we use our formula, Q1 minus 1.5 times the IQR, or 0.39 minus 1.5 times 0.26, which is going to give 0. Now, we've calculated the lower fence, but we need to actually show that it's not an outlier. So we can just say 0.22 is greater than 0, therefore not an outlier. Okay. Then we've got a least squares line between LLT and HHT, where HHT is the response variable. So that one's going to go there, and then LLT is going to go there, and then back to our CAS. Sorry. I don't know why it's doing this. I can't move this, that's why. Sorry about that. All right, so back to our CAS. All right, we have LLT and HHT, so we do menu 414, Now, X list is explanatory, so that's LLT. And then our Y list is our response, so that's HHT. Push enter, and then we're going to go up and have a look at A and B. So A and B are there for us, and we want 4 significant figures. So the first 4 numbers, so 2.130. Now that 0 is important because it is a trailing 0 after a decimal point. And then our other one was negative 1.054. And that's a plus, so we need to make sure we write the negative 1.054. Okay. Next, we've still got the same variables that we're using. Use the data from table 3 to complete the frequency table. So for LLT, we've got 2 befores, 1 on, and the rest are afters, and there's 9 because it's got to add up to 12. For HHT, we've got 3 befores, 3 ons, and the 6 is the rest because they have to add up to 12. Okay, does the data in table 4 support the contention that the occurrence of LLT is associated with the appearance of the new moon? Now, we only care about LLT here. Explain your conclusion by comparing the values of appropriate percentages. So we're going to find the percentage of this. So 9 out of 12 times 100, that is 75%. Then we've got 1 out of 12 times 100, and that is 8.3 recurring percent. And then we have 2 out of 12 times 100, and that is 16.6 recurring percent. Now, you would just check that on the calculator, but I already did those ones. All right, so we would say yes. And it supports the contention because this is obviously much larger than those ones. So we would say 75% of LLT occurs after a new moon, which is higher than on at 8.3 recurring percent and before at 16.6 recurring percent. All right, next. Okay, so the time distance between successive high tides and low tides are approximately normally distributed. So normally distributed means we're going to need to use our bell curve. The analysis of 2021 tide chart shows that. All right, so we've got 99.85 and 16. Now, I'm always going to put in my mean, which will be there, and my 2 ones here. Now the 2 here are going to be 68%. The next ones are going to be 95%. And then the last ones, they're going to be 99.7%. Okay, so 99.85 is what's going to be here because we know we've got 0.3 left over, which is going to be split between 0.15 and 0.15. So this one is going to be 4.88. The next one, 16% of time differences is less than. Now 16 sits with the 68 because that's 32 left over, which means 16 are going to be on each side. So 16% of the time differences are less than. So that's less than, so that's this side. So that's going to be here, 5.76. Now, those are the 2 values that are important. Now we know we've got 2 standard deviations between them. So what we're going to do is we're going to take the smaller one away from the bigger one, and that's going to give us 0.88. And then because that's 2 standard deviations, we're going to divide that value by 2, and that's going to give us 0.44. Okay, if you can't do that maths in your head, that's totally fine. You just need to use a calculator for it. Okay, and then what we have here is 1 standard deviation away from the mean. So then we take our 5.67 again, and we're going to add our standard deviation. And that's going to give us 6.2. Okay, so our mean there is 6.2. So it is really important that we know how to set one of these up and that we're aware of not just the rule itself, the 68, 95, 99.7, but we're also aware of what's left over. So it might be good to have one of your tables in there that shows you what all of these different sections are. Okay, next. We're still dealing with highest high tide and lowest low tide, and we've got a scatter plot now. So we've got an equation and we have a coefficient of determination. And it might just be important for us to write r squared there, just so that we know we're dealing with r squared and not r. So draw the graph of the least squares on the scatter plot above. So in order to do this, we have to actually use our values to calculate what we have. So it's going to open up a new page. Okay, so we've got our equation, which is 2.19 minus 1.08 times. Now, I always use the first value and the last value to do this. So we've got that, and then we've got 2.19 minus 1.08 times 0.64. All right, so we've got 1.974 and 1.5 approximately. Okay, so the top one is 1.97. So again, these are 0.2. So 2, 4, 6, 8. So 7, 4 is going to be in there. And then 1.5, which we can use perfectly. Now, you guys will use a ruler. I don't have the luxury of one of those in here, but it is really important that they're sitting at the right points. Okay, determine the value of the correlation coefficient R. So that means that we're going to square root what we've got. Okay, so the square root, where's my square root, of 0.4709 equals, now we want 3 decimal places, so 0.686. And just remembering to check my slope is negative, but also we can see that my line is negative, so that is a negative 0.686 there. All right, moving on, describe the association. So form is either linear or non-linear. This one in this case is linear. And then we've got our direction, which we just talked about being negative. So that is negative there. Interpret the slope. So the slope is 1.08 of the lines in terms of these. All right, so on average, now remember this is just a formula in your book or just a sentence in your book. You just have to fill in the information. On average, for each additional 1 meter in LLT, we could also use additional / increase. Sorry. The HHT, now it decreases because that's a negative, decreases by, and my slope is 1.08 meters. In this investigation, the HHT value is 1.88 and LLT is 0.4. So we're going to show the residual. So residual is always actual minus predicted, which means I have to find my predicted, and we always predict from X. So we've got 2.19 minus 1.08 times 0.4. We're just going to put that in the calculator. So 2.19 minus 1.08 times 0.4. Whoops, helps if I was actually writing it. 2.19 minus 1.08 times 0.4. It's going to give me 1.758 equals 1.758. And then I know that my actual was 1.81 minus the predicted 1.758 equals, now it does tell us what the answer is, but it's always good to do it yourself just to make sure that you have the right one. So 1.81 minus 1.758 equals, now that is indeed the same answer as the other one, so as what's given to us, so we know that we are correct. Okay. And remember, we have to show every single step, so you have to show this part and then you have to show that part. just get rid of those ones because they're not important. Okay, the mean HHT values is that. Calculate the mean of LLT. Now, in this case, we're not actually given the HHT or the LLT, so we have to find another way to do this. Now, the way that we're going to do it is we're going to use our formula. So A equals the mean of Y minus B, mean of X. Okay, now this formula and the one for B is really, really important that we have them written somewhere that's really easy to access because they have been popping up more and more in exams. So A is my 2.19. Now my mean of Y is my mean of my response variable, which we know is HHT, so that's 1.7 minus, and then B is my slope, so minus 1.08 times, and then I don't know what my mean of X is, so I'm just going to leave it there. Now, this part is really important because it's a minus in here, but then it's also a minus in my slope. So it's really important that we do have that negative twice. And then we are solving for that, so solve, and we would say 2.19 equals 1.7 minus negative 1.08 times X, comma, X. Okay, and tells us that X is, we want 2 decimal places, so X is 0.45. Okay, and I'm just going to put a bar over the top of that just to make it really clear that I mean the LLT mean. Okay. Now, you don't have to write out a sentence because it is only worth 1 mark, in which case they're just looking for the answer. All right, now this is obviously going to be a time series graph. Again, we're using the same variables here. And this is just one question. So 3 years of data shows in the graph, and table 5 will be calculated, used to calculate seasonal indices. Determine the seasonal indice for March. Now it hasn't specified a year, which means it wants the average seasonal index. Okay, so that means I have to find March in all 3 years. So March is the 3rd month, so 3, 15, and 27. So for the first one, I've got 1.87 over my first year, plus the second one I have 1.92 over 1.99, and then the third one is 1.93 over 1.96. We're just going to put that in our CAS. Okay, whoop, go down. All right, 1.87 over 1.98 plus 1.92 over 1.99 plus 1.93 over 1.96. Okay, and then I have my answer, but that's my answer across all 3 years, and I just want my seasonal index, so I have to divide it by the number of years, which is 3, and I get 9.6. Hang on, I've made a mistake somewhere. Okay, I've just made a little mistake here. This is actually 89, not 87. Okay, and then divide that by 3. That's better. Okay, so let me just fix this up here. That's 89, which gets me approximately 2.9, which I'm going to divide by 3, which gives me 0.97, and I'm just to 2 decimal places, so that's my answer there. Okay. All right, number 6 is again another time series, and it looks like it's also just a 1 mark question. So, question down the bottom. Both the HHT data and the LLT data have been smoothed using something median smoothing. All right, so we know that when we smooth with a median, we know that to smooth with 3 median, we actually don't smooth the first point. Same as when we do a 5. We actually can only smooth the first time we have 5 data points. So there, we've actually got 2 that are not smoothed. So how many do we have not smoothed here? We've got 1, 2, 3, 4, 5, 6, 7. So that means the 8th bit of data is the first point. So if I've got 7 on this side and 7 on that side. 7 plus 7 is 14, plus the 1 data piece is 15. So that is actually a 15 median smoothing. All right, recursion and financial modeling. So what amount of dollars did Cleo borrow? She borrowed 5,000. Now, unlike data, it's often really important to read all of the information in a sentence for finance. So it's a reducing balance, monthly, 20 years. So I didn't read it for the first one, but you can see that later on I would have needed that. Determine the total value in dollars of the repayments made by Cleo in the first year of the loan. So she makes this many, she makes 4,012 payments per month. So I've got to times that by 12. Okay. So 4012 times 12. So her total repayments are 48144. 48144. Now, again, these questions are just worth 1 mark, so you don't have to show working out. I sometimes do, just because that helps me get my brain around what I'm thinking. So the interest rate for Cleo's loan is 6% per annum. Use this value in a calculation to show the multiplication factor. Multiplication factor is just R. In the recurrence relation is that. So it's basically just asking, how do we get R? So to get R, we do 6 divided by 100 times 12 plus 1. And that's going to give us 1.005. But in this case, that's just what they were asking. All right, complete the next line of the amortization table. So we've got repayments. We know that is 4,112. And then we've got interest. Now, to do this, I'm just going to use 0.005 because I know that's my monthly interest rate. So 0.005 times 560,000. So that means my interest amount is 2,800. Now my principal reduction is just my payment, 4012 minus my interest. My principal reduction is 1212. And so then I need to calculate my new balance minus, I'm just going to grab that. Okay, so we've got 558,788. 558,788. All right, the final monthly payment will be higher than the previous payments to determine the value of the final payment. All right, we can only do this using Finance Solver. So menu 8.1. Now, I was doing monthly for 20 years. So 12 times 20 is my N. My interest rate is 6%. And I borrowed 560,000. Now my payment amount is 4,012. I want to find that, and my PPY is 12. So I want to find my future value, which is 644. Now the signs are the same, which means that we add them, but also we can tell because 644 is still owing because the negative means it has to still come out of my account. So I'm just going to have 4012 plus 644, which is just going to give me 4,018.44. Okay. Okay. Cleo owns equipment purchased for 50,000. She depreciates the value using unit cost method. And then we have a recurrence relation that looks like that. Okay, what does the K represent in this recurrence relation? So it represents the depreciation per unit of use. So if K is 12.5, determine the value of the equipment 1 year after it is used twice per day on all 365. So we can sort of set up a rule for this. 50,000 minus 12.5. Now I'm using that for 365 days and I'm doing it twice a day. So on your CAS, 50,000 minus 12.5 times 365 times 2. So that's 40,875. Okay, so that's what its current value will be. Another option for Clio is to depreciate using reducing balance method. If the depreciation rate per month was 1.85, what would it be? So 100 minus 1.5 is going to be 98.5, or an actual value of 0.985. Now I'm actually going to rub this out because I wouldn't recommend you actually physically writing that. We should just write the answer here. If you want to do a little bit of working out, do it off to the side. For what value of R would the equipment be valued at this after 3 months? All right, so 42868. 42868.75 equals R to the power of 3, because it's 3 months, times the original value. Now again, I've just taken that from the rule because I'm looking at things in the future. So that's a solve problem. So 42868.75 equals R to the power of 3 times 50,000, comma R gives me 0.95. So R is 0.95. Now, I'm probably writing a bit more than you have to because I want to be able to see what I'm putting into the calculator so you guys can see. You probably wouldn't need to write anything other than the answer there. Okay. Next. So Cleo took out $35,000 for an overseas holiday. Interest is charged at 10% per annum, and she makes payments of that quarterly. So we're just writing a recurrence relation here. Make sure that you're matching the letter that's there. So V0 is 3,000 or 35,000, sorry. Vn plus 1. Now we're doing 10 divided by 100 times 4 plus 1, which gives us 1.025. Bn minus 1722. Fix that up so it looks better. 2. Okay, for the second year of the loan, Cleo increased her quarterly repayments to $2,000. Determine the total amount of interest paid in the first 2 years. Okay, so this is 2 marks, which means it's going to have a couple of different things in there. So the first thing I'm going to do is I'm going to figure out how much Cleo paid in the 2 years. So she made its quarterly payment. So she made 4 payments of $1,722 and 4 payments of $2,000. So 1,722 times 4 plus 2,000 times 4. So 1,488.8. So that's how much she's paid. Now, what I have to find out now is how much the loan has decreased by. Now, again, that's going to have to be a finance solver type problem. Because it's only 8 payments, we could actually do it using a recurrence relation, but most of the time questions like this will require finance solver. Now, we've got 2 different payments, which means our condition's changing, so I have to calculate each of them individually. It's going to be 10, that's 35,000, that's minus 1,722, and this needs to be 4. Now, what I'm going to do is I'm going to calculate my future value after 1 year. Then we can copy that and paste it into the new PV value. Now, I'm not going to change the sign there because I'm just going to change the sign of the payment instead. Now, everything else stays the same. We're looking for 1 more year, so N stays at 4. My interest rate's still the same. It's just my PV that's moved. And then I'm looking at how much it is left now, and I'm going to copy that value. Okay, so that's how much is left, which means that I have to find out how much it depreciates by. So it started at 35,000 and it's decreased this much. So that has actually reduced the value of the loan by 8,553.89. So it's reduced by 8,553.89. And we know that to find the interest, I have to take my total repayments minus how much it's reduced by. So once again on CAS, minus, and again, I'm just going to grab that value. So 633411. 633411. So that's how much interest has actually been paid. All right, matrices. All right, so an egg farmer has 5 barns. Matrix H shows the communication links. All right, so this is just usually telling us exactly what we already know. 1 means you can communicate, 0 means you can't. Which barns can correctly communicate with L? So L as a receiver means K and M can both communicate with L. State 2 communication paths for J to communicate with K. So I want J to be able to communicate with K. So J at the moment can only communicate with M. So J has to go to M, and then M can communicate with K. But there needs to be 2. So let's have a look at another one. Now we know that J has to go through M because that's the only one that J can actually communicate with. Now, there's no point for M to go back to J. We've already done K, which means M must communicate next with L, and then L can communicate with K. So J, M, L, K. All right, so the farmer plans to install 1 new direct communication link in 1 barn to receive communication from I. Okay, so that means I is the sender. Okay, which barn should the new communication link be installed to ensure that barn I has either 1 or 2 step with every other barn? Now, what we can see here is that, what we can see here is that M is the most useful because it communicates with J, K, and L. The only one it can't communicate with at the moment is I. But if I sends a message to M, then M can then communicate to all the other ones. So that means that M is the one that has to be there. Now, it can't communicate with J, or could communicate with J, because J could then communicate to M. And then it could communicate with K, but M is the most logical one for it to get to. Okay. Next, so the farmer sells 4 different size eggs in jumbo cartons containing 12 eggs. So this is the total weight. This information also displayed in matrix E. All right, so that's matrix E. So complete the following matrix equation that calculate the average egg weight in a carton for each egg size. Okay, so this says that 504, the carton weighs 504, but there are 12 eggs in each carton. So realistically, we have to divide by the number of items. So that would be the same as dividing by 12, which we can't do with matrices. So instead, we will times by a half. Okay, and then so what we do is 504 divided by 12. We do 600 divided by 12. We'll do 696 divided by 12. And we'll do 804 divided by 12. And so we get 42, 50, 58, and 67. 42, 50, 58, and 67 as my values there. Make sure that every box or every line is filled in here. So on one day, the farmer sold 122. All right, so that information's there anyway. In the space below, write a matrix calculation. So that means we need the whole calculation using Q and a column matrix to show the total number of eggs sold. And we want to sell it so that it is that. Okay, so we want a column matrix, and it's going to end up with a 1 by 1. So Q is a 1 by 4. So we want to multiply it by a 4 by 1 because that'll give us a 1 by 1 as my answer. So Q has to go first. So 504, 600, 696, and 804. We want to times it by. Now we want the total number of eggs. So each carton has 12 eggs. So we want to do 504 times 12, 600 times 12, times 12, times 12. So we want to multiply all of these by 12. And that answer there is going to give us 4824. Now we're told that, but we just want to check to make sure that we are correct there. So I've got 1 and 4, and we want to fill it in 504, 600, 696, and 804. And we're going to multiply that by a 4 and 1 of 12, 12, 12, 12. And we want that to equal, whoop, nope, so that doesn't work. That's because I used the wrong matrix in the first place. Whoopsies. But this is why we check. So this is not the matrix that we need to use. In fact, we need to use 1, 2, 2, 1, 4, 8, 80, and 52. Okay, let's try that again. So that's 52. That's 80. That's 148. And 122. And now we have the right answer. Okay. Good. Oh, blank page. Alrighty. 3 types of eggs are sold at a local supermarket: cage eggs, free range eggs, and barn laid eggs. So this is a transition matrix. So this is a proportion. Okay, and that's that. So first part, an incomplete transition diagram exists. Complete the transition diagram by adding the missing edges. All right, so let's do F to F. And F to F is 0.7. We then have F to C, but we don't have F to B. So F to B is 0.15. Okay. Next, we then have, oopsies. Okay, we then have C to F. C to F is 0.2. C to C is 0.65. And then we need B to B, which is 0.45. And we need B to C, which is 0.25. Okay, so diagram is completed. All right, so how many weeks after the campaign begins are there more than 44% of customers to be expected to purchase free-range eggs? All right, so I have already input my transition matrix just to make... Oh, no, apparently I didn't. Did I already input my transition matrix? Nope, apparently I didn't. I'm just going to enter that and then get rid of it. Okay, so my transition matrix is going to be a 3 by 3. It's 0.65, 0.2, 0.15, 0.15, followed by 0.15, 0.7, and 0.15, and 0.25, 0.3, 0.45. Okay. Now, the question is saying how many weeks after the campaign begins will more than 44% of customers first purchase free-range eggs? So, I'm going to start by putting in my S0 matrix. That is a 3 by 1, and it's 0.4, 0.4, and 0.2. Okay, now I'm going to set this up so that I can count as we go up. So times, and then I'm going to use times A and S, okay, because I can't just do times first because the order is really important there. Now, F is my middle, so I'm going to look for my middle number first being above 0.44. So 1, 2, 3, 4, 5. So that's 5 times. So the answer here would be 5 weeks. Okay. For the duration of the 10-week campaign, 2,000 customers purchased eggs at each supermarket. Identify the expected number of additional shoppers who purchase free-range eggs at the end of the campaign compared to the start of the campaign. All right, so I've got 0.4, 0.4, and 0.2, and there's 8,000. So we're going to have 0.4 times 8,000, which is going to be, sorry, there's not 8,000, there's 2,000. 0.4 times 2,000, 800. Okay, 2,000. So that means that 0.4, that means it's going to be 800 people buying free range. Okay, so now I want to find out what's going to happen at the beginning of the campaign. Now, I'm at the end of the campaign. So the campaign lasts for 10 weeks. Okay, so pen's decided it doesn't want to work. Okay, so I'm just going to change these to be the right number. Okay, so I'm going to need 800, 800, and 400. Okay, oh, but I forgot to raise that to the power of 10. So I'm going to raise this to the power of 10 because I want to know what happens in 10 weeks' time. Okay, so we can see here that we're looking at the third one, and the third one is 885.6, which means that would be 86 customers. Okay, the farmer believes that their free-range eggs are so superior that the shoppers will eventually stop purchasing cage eggs and barn-laid and only buy their free-range eggs. Complete column F in the following transition matrix. All right, so F to C, well, if they're so superior, once you obviously try the free range, you're never going to go back. So F to C is going to be 0. F to F is going to be 1 because everyone who buys free range will stay at free range, and therefore that is also going to be a 0. Okay, a farmer has 4 fields for chickens to roam in during their stay. The fields are named north, east, south, and west. How original. The following transition matrix is used to determine the expected proportion of chickens that will either change fields from one day to the next or stay in the same field on consecutive days. There are initially 10,000 chickens in each field. After one day, how many chickens are expected to remain in the same field that they were in initially? Now, that is going to be our leading diagonal. So we're going to have 0.3 times 10,000 plus 0.28 times 10,000 plus 0.12 times 10,000 plus 0.19 times 10,000, which will be 3,000 plus 2,800 plus 1,200 plus 1,900. Oh, sorry. Don't know where that came from. Go away. Wow. Go away. All right. And then we're just chucking that in the CAS. So 3,000. Oh, there we go. 3,000 plus 2,800 plus 1,200 plus 1,900 is going to give me 8,900. Great. After 2 days, 869 chickens were expected to be in the north field. How many of these chickens are expected to have been in the north field initially? Okay, so this one we can't actually use the normal state transition stuff for because we are not looking at every single chicken. We're just looking at certain ones. So what we have is in the north field, we have 0.3 of them staying, and we said that there were 3,000 that stayed. Okay, so that is going to be 900. Okay, but we also have, I'm just going to delete this, because we also have chickens that stayed one night in a different field and then came back. So we know that on this day, we had in the north, we had 14% that went to east. So that means that of the ones in north, 14% of them, so 1,400 of them went to east. And then of those 1,400, 12% came back. So 1,400 times 0.12. Okay, 0.12 times 1,400 is 168. Okay, and then we follow that same process for all the rest of them. So we had 24%, so that is 2,400 that went to south, and then south that went back to north is 30%. Okay, so south that went back to north times 0.3 is 720. Okay, and then we had the ones that went to west. So 3,200 went to west, but then 20% of them came back. So 3,200 went to west, but 20% came back. So that's 640. And then we just have to add those up. We had 900 plus 168 plus 720 plus 640. 900 plus 168 plus 720 plus 640. So that is 2428. Okay, so that one's a bit of a hard question, and it's only worth 1 mark, so there's not really a lot of indication for how much work was actually required. So we just want to try and keep a mind out for the kinds of things that are triggers here. So how many of these were expected to have been in the north field initially? Obviously, the fact that we've got a 2-period jump is a key there for the fact that we've actually got people from the day 1 that moved and then have come back. Okay, of the chickens expected to be in the east field after 3 days, what is the percentage of chickens that were expected to be in the east field after both 1 day and 2 days? Okay, so firstly, we need to find out how many of them are there on the 3rd day. So that's just going to be our transition matrix times our initial matrix with our transition rates to the power of 3. So we're just going to have to put that in. That is a 4x4. Okay, so we've got 0.3, 0.14, 0.24, 0.32. All right, sorry, all set up now. You didn't have to watch me do that. So what we can see here is that after 3 days, oops, I forgot to raise it to the power of 3. After 3 days, we have we just want this one, 11292.8. So after 3 days, 11292.8. That's how many are in the east field. Okay, so after what we need to do is we need to work out how many there were after 1 day. So that was this one. So after 1 day, we have 11,100. So 1 day, we have 11,100. Okay, so what we're looking at is how many on the east field for both 1 day and 2 days that are then still there now. So we need to look at east to east. So heading back up, east to east. Just get rid of these. east to east is 0.28. Okay, so that means we've got 0.28 of the easters there are still there. Okay, so 0.28, bring it down, 0.28 times 1100 is 3108. Okay, so that's on day 2, and then we have to times that again by another 0.28 to get how many are still there on day 3. Okay, because you've got to have the easters have got to be there on day 2 and then still be there on day 3. So that's the number that we're actually looking at. Okay, so that actually needed to be to the power of 2. And what was that number? It was 870.24. Okay, so that's how many were there still, and it's got to be as a percentage of that. So 870.24 over 11292.8. And then we just put that into the calculator. This one divided by 11292.8 times by 100 to get it to a percentage. And we have 7.7. We want to the nearest whole number, which is then 8%. Okay, so again, there's not really an indication of how much work that one actually takes. But once again, we're looking at both days. So that's can indicate how much we actually have to do for that question. All right, networks. All right, which friend plans to visit the most attractions? So again, I skipped a lot of the reading part, but which plans to visit the most attractions? So basically we're looking at which one here has the most lines coming off it. That one is obviously going to be Ben. How many attractions have only one friend planning to visit? So this time we're looking at this side. So there's 3 there with only one line coming off it. Okay, when the friends arrive at the theme park, it's only time to visit one of the attractions they had planned. If the minimum number of different attractions are visited, what are the names of the attractions? Okay, so we want to have the minimum number visited. Now, we know that Andrea can only do the Ferris wheel. So the Ferris wheel has to be there. Okay, the Ferris wheel has to be there. Now, we've got 1 on the tilt-a-wheel, but Elliot can also visit here. So let's also add the roller coaster. Okay, and what I'm actually going to do is I'm actually going to cross off people as I go. Andrea's done. The roller coaster gets both Delaney and Elliot. So now all we're looking at, is there one that Ben and Kathy both will do? And it looks like there is. Ben and Kathy will both do bumper cars. So bumper cars. Okay, and that's the 3 attractions there. Okay, so we're looking at the theme park. There are edges and they represent paths. So Rowan works for the theme park collecting money from the ticket booth at each of the attractions. To do this, he visits each attraction once, starting and finish at the entrance, which means he's going doing a cycle or a circuit. So what is the mathematical term used? Now, basically, we just have to decide, is he visiting all paths or is he visiting all vertices? In this case, he's visiting each attraction. So therefore, that is going to be vertices. So this is a Hamiltonian. And he's starting and ending at the same place. So that is a cycle. Write down one possible route Rowan could take. So the entrance is here. And we just have to make sure we visit all the attractions and then come back to the entrance. So let's do E to B to T to F to R to C to M to E. Now there are different ways you can go because it says one possible, so that might not be the one that you got, but that is just one of the ways that we can do it. And back to E. Okay, all right, so next. An inspector is called to check all the paths of the theme park. All right, so now we're talking about paths. The inspector would like to walk a route that travels along all the paths only once, starting at the entrance. With reference to the degrees of the vertices on the graph, explain why the inspector is not able to walk such a route. Okay, so he wants to start at the entrance, but there's no thing that's saying he has to finish at the entrance, which means that we're looking for an Euler trail. Okay, so in order to have an Euler trail, we can only have two vertices that are odd. In this particular case, we have, that's 3, that's 3, that's 3, that's 3. So we actually have 4 that are odd. The rest of them are even. Okay, so why can't we? Because more than 2 vertices have an odd degree. So that is simply a definition. So the inspector decides that the path between bumper cars and tilt-a-wheel needs to be closed for maintenance. All right, so bumper cars and tilt-a-wheel needs to be closed for maintenance. All right, so that means that's going to go. Okay, the next day, Rowan will again need to collect money from the ticket booths at each of the attractions, starting and finishing at the entrance. To do this, Rowan may need to visit one or more attractions twice. If Rowan visits each attraction starting and finishing at the entrance, what is the length of the shortest path Rowan can take in meters? All right. So these ones take a little bit of like guess and check. So I'm going to use some different colors here to see how we go. So which path should he take twice? I'm probably going to say if he can, M would be a good one to take twice because it is the lowest amount of distance. So let's just say he does that. So he goes, so he does E to B to C to M and back to R to F to T to E. All right, now we can be pretty certain that these bit from C to R, so here, is pretty set in stone. We don't need to go back to C. We have to get R, so we're going to have to go along that way. So that part's pretty set in stone. So now we just have to work out how long that one takes and whether there's going to be a shorter one. Now, I guess the only other way we could do is we could do E to M to C to B and back, but that's longer than 33. So I would say that that is probably not the right pathway. So now we just got to add them up. So we've got 37, 35, 33, 33, 55, 51, 62, and 65. Okay, so we're just going to add those ones up. 37 plus 35 plus 33 plus 33 plus 55 plus 51 plus 62 plus 65. We get 371. Now, there is a lot of trial and error when we deal with networks, but pretty confident based on that process that it's going to be 371 meters there. Okay, the tilt-a-wheel attraction is to be upgraded. It will be closed for the duration of the upgrade. The upgrade involves 12 activities. So here we go. All right, now I'm just going to put my boxes in. Start with. Okay, now remember I always put my boxes on the activity rather than on the node, so that each activity gets its own special mention. All right, which activities have exactly one immediate predecessor? So C has one immediate predecessor. D and E both have one immediate predecessor. And L does not. And J does. Okay, so J. So D and E both have B, C has A, and J has I. I has both of those, so all those ones are out. G's out, that's out, and L's out. So it's just those 4. Okay, what is the minimum number of days the tilt wall needs to be closed to complete the project? All right, so now we just have to go through. This one is a bit time consuming, but we just have to get it done. So 0, 0, 5, 5, 5. Now, F and I, 5 plus 7 is 12, 5 plus 6 is 11, so 12 for those two. And that's then going to be 15. Oh, that's also going to be 12. And that's going to be 15, which means this has to be 19. J is going to be 16. Now 19 plus 5 is 24, which is higher than that one, so we take the highest one, and then that's going to be 26. So 26 days. Going to be that one. All right, what is the latest starting time for activity I? All right, then we just go backwards. 26 minus 2 is 24. 24 minus 5 is 19. 24 minus 6 is 18. 19 minus 3 is 16. 19 minus 4 is 15. And then 18 minus 4 is 14. So 14 days. What activity has the longest float time? So we just keep going. 15 minus 3 is 12. 15 minus 5 is 10. Pick the lowest of these. So 12 minus 7 is 5. 5 minus 5 is 0. 14 minus 6 is 8. And 8 minus 5 is 3. So the longest float time is definitely going to be E there. All right, crashing. So the management of the theme park decides that the tilt-a-whirl attraction will be closed for too long. They give the project manager budget to reduce the completion time. So the project manager is able to hire extra people to reduce the time of these activities. So we can only reduce A, B, D, E, G, and H. So I'm just going to color those ones in. We can only reduce A, B, D, E, D, E, G, and H. G and H. Okay. Complete the table below showing the reduction in the individual activity times that would achieve the maximum reduction for the minimum cost. Okay. So, alrighty. So let's have a look at what we need to do. So, looking at these, we can see that D is the most expensive. So we want to try and avoid D if we can. E is the cheapest, but we definitely won't be reducing E because it's already got a float of 5 days. So we definitely don't need to reduce that one. Okay, so let's say we do reduce that to 3. So then this one will become 3 and that will become 9. So let's see if we can get everything else going there to become 9. So that would be 9. This would be 9. So basically this pathway here needs to be 9. So we've got 5 and 7. We can reduce them. So 5 and 7 is 12. So we need to take 3 off them. Now we said that D was the most expensive. So if I take 1 off D, I can take 2 off B. And that way that's going to be 9. So that's going to work. Let's see if we need to remove anything else. So that becomes 9. That's 3. That's 6. So that's 9, which means this becomes 12. Now G I can reduce. So let's go ahead and reduce G to 2 because I can take 2 off that. So then that becomes 14. That becomes 19 and that becomes 21. All right, so that was my previous critical path. So now I'm just going to make sure everything else is going to fit into 21 as well. So 9 and 4 is 13. 13 and 6 is 19. 19 and 2 is 21, so that works. All right, this is 9. 9 plus 3 is 12. But that's already 13. So I don't actually need to cut H at all, because it's not going to change anything. So H can be 0 days. Okay, and everything else makes 21. So what else did I cut? I cut A by 3, A by 2 and B by 2. So A I cut by 2 days. B I cut by 2 days. D I cut by 1 day. And G, I cut G by 2 as well. Okay, I'm just going to check how much that costs. So 2 days, that's 4,000. 2 days, that's another 4,000. 1 day, that's 2,500. And then that's 3,000. So what's that? 8, 11, 13,500. Could we cut anything else? H has a float of 4, so we can't cut anything there. E has a float of 5, so we can't cut anything there. But everything else still makes my way through. So no, I think that's all we can do. And that is the end of the paper. Thanks for watching.